So let's continue from where we left. Example number 7. Compute determinant of 5 minus 2, 4, 0, 3, minus 5, 2 minus 4, and 7. So that is actually a single number that we get from the matrix. It's a single number that we get from that matrix. Now, how can we get the determinant here? So previously, I gave you a remark where we said we're using the cofactors. Then you look at the row or the column which has as many zeros as possible. It has as many zeros as possible. So we can actually get the determinant by using the first row here, since we have a 0 here. So when we use the cofactors method, then it will actually be, so the solution. So in this case, then the cofactors that we get when we delete the first row and the first column here is actually C11. So in that case, to get the determinant of this matrix here, let's say A, then A is now equals to 5C11. And then we come to the second one here. When we delete the second row and the first column here, then in this case, it will be 0 plus 0 C. Since we are deleting the second row and the first column will be C21, and then plus, since we are deleting the third row and the first column, then it will be 2C31. C31. So, and we remember how we were getting the cofactors. Now here, then it will now be the determinant of A is equals to 5 multiplied by -1 ij. So we are deleting I, which is 1, I, which is 1, and j, which is 1. So it will now be 1 plus 1 here. 1 plus 1. And then determinant of, we have deleted this and this. So determinant of 3 minus 5 minus 4 and 7. Minus 4 and 7. Now, since this one will be 0, then we can do what? We can just ignore it. Since this one will be 0. So we just go to the third one here. So plus now 2 multiplied by -1. We are deleting the third row and the first column. So it will be 3 plus 1. And then determinant of, we've deleted this and this. So it will be -2, 4, 3, and -5. So that is how we use the cofactors. Then now, so determinant of A will now be equals to 1 plus 1 is 2. Anything raised even number will now be positive, so we get 5 here. Now, determinant of a 2 by 2 matrix, 3, so multiplied by 7 multiplied by 3 minus 4 multiplied by 5 minus 5 there. Minus 4 multiplied by minus 5 plus 2. This is 3 plus 1, which will give us 4. That is even. So this will be positive, so it will be 2. And then minus 5 multiplied by minus 2 minus 3 multiplied by 4. 3 multiplied by 4. So finally, this will be 5 and then 21 minus, so minus 20 plus 2, 10 minus 12. 12. So finally, this is equals to 5 multiplied by 1 plus 2 multiplied by minus 2. And this will give us 5 minus 4, which is equals to 1. It's equals to 1. So that is how we use the cofactor. So you actually use the one which has as many zeros as possible. You can actually also use this row, the second row. So it will give you the same answer. Another example number 8. If we are told to compute determinant of 6, 3, 2, 4, and 0, 9, 0, minus 4, 1, and 0, 8, minus 5, 6, 7, and 1, 3, 0, 0, 0, 0, and 4, 2, 3, 2, and 0. Find the determinant. So again, you look at the row or a column which has as many zeros as possible. So in this case, you can use the third row here. So using the cofactors, then this will now be equals to, the determinant will be equals to 3. So in that case, that is 3. And then using the cofactors method, this is minus 1. So we are at what? We are deleting the third row and the first column. The third row and the first column. So it will now be 3. So 1, 2, the third row of the fourth, actually the fourth. 4 plus 1, plus 1. 4 plus 1. The fourth row. So 4 plus 1. And then now we get a determinant of what? The determinant of 6, 3, not 6, sorry. It will, we are deleting this and this. It will now be 3, 2, 4, and 0, 0, minus 4, 1, and 0, minus 5, 6, 7, and 1. We have deleted this. So we have 2, 3, 2, and 0. Okay. So that is what we get from that. So you continue again the same way. What we've done here on this, we continue again. So in this case, this is 4 plus 1. So this is giving us what? So it is giving us a negative. So actually the next one will now be -3. Now, -3, and then what are we doing? So -3, and then we now, which one has as many zeros as possible? So this, right? The 1, 2, 3, 4, the fourth column. So we can delete this. So it will now be minus 3, which you get from here, multiplied by 1, yeah, multiplied by -1. In this case, this is what? This is the 1, 2, 3, the third row, which is the third row, plus the fourth column, 3 plus 4, 3 plus 4. Then we get what? Determinant of, we have deleted this and this. So we get a determinant of 3, 2, 4, 0, minus 4, 1. And then the last one here is 2, 3, and then 2 there. Okay. So this 3 we're getting from here. So we're getting here. And then now we delete this and this. So what remains is the determinant of this. Now, this is 3 plus 4, that is 7. So this is negative. So this will be positive. All of that is positive. The same way, do the same way here. Now, this 3 and this minus 1, now it will give us 3. So 3. So which one has more zeros here? So this you can use that. You can actually use this column here. So 3 outside, and then 3 multiplied by -1. We are deleting the first row and the first column. So it will be now 1 plus 1. And then determinant of what? Determinant of -4. We are deleting this and this. -4, 1, 3, and 2. Okay. Plus, we are deleting, so this will give us 0. Yeah, this will give us 0. And then plus this one now, 2 multiplied by -1. We are deleting the the third row and the first column. So it will be 3 plus 1 there. Determinant of 2, 4, and then -4 and 1. It's 4 and 1. So up to there is now easy. Yes.
Where did the 2 come from?
So 2 is this. So we are using this row here. Okay. So now we are using this column here. So this is 3 for this, and then we are deleting the first row and the first column. So 1, 1. And then what remains is. Now the next one is 0. So when you multiply it by 0, it becomes 2 multiplied by, we are deleting the third row and the first one, 3 plus 1. 2, 4, 2, 4. So from here now, you are able to get the answer. So 3 outside, so 1 plus 1 is 1. So this will be 3. Now you can use 2 by 2 there. So finally, what we get is 3. So we get 3 here multiplied by, so this is -8 minus 3 plus 3 plus 1 is 4. So this is giving us positive 2, 2 plus 16. So finally, this is equals to 3. So -8 minus 3 is minus 11. So minus 33 there. plus 16 plus 2 is 18, minus 2 is plus 31, 36. And this is giving us 3 here, and finally this is equals to any question?
How do you know which position to delete when it's a big matrix?
So you look at the row or the column which has as many zeros as possible. Okay.
Okay, and then you kind of work your way until you have a 2 by 2 matrix.
Yes. Yes.
Okay.
Look at the row which has as many zeros as possible. The row or the column, either way. Yeah. The row or the column. You can either use this. You can use this. So it will give you the sentence. As long as you know how to use the core. So these are this 1 plus 1 are the ones which you are deleting. Okay. So we are deleting the first row and the first row and the first row. We are deleting the first row and the third row and the first row. So you need to know which one is which is which. Okay. Any question? Any other question? Okay. Let's see another example. Example number 9. So compute the determinant of -4, 2, 0, 0, 2, 3, 1, 0, 3, 1, 0, and 2, then 1, 3, 0, and 3. Compute the determinant. So which one do you want us to use? Which one do you want us to use? That row, right? So we can delete the third row. So we can delete the third row. This one has many zeros. The third row here. So it has many zeros. So the determinant here will now be equals to 1 multiplied by -1. So what are we deleting? We are deleting the second row and the what? Third column here. The second row is 2 plus the third column there is 3. 2 plus 3. Okay. So we are deleting the second row plus third column there. And then now we do what? We get a determinant of, we are deleting this and this. So -4, 2, and then 0, 3, 1, and then 2, and then 1, 3, and then 3 there. Okay. Okay. So we deleted this and this. So what remains is -4, 2, 0, -4, 0, 3, 1, and 2, 1, 3. Okay. So this is actually 2 there. 2, and this is 2. Right? Then this is now equals. So 2 plus 3 is what? 5, right? So this will give us the minus, so -1. So you can put it outside there, okay? Now, which one has as many zeros as possible? We can do what? We can delete, we can either use this or use this. So let's use this. Okay? Let's use this, the third row. Let's use the third row there. So let's delete this. So in this case, this will be 0. So we ignore that. Then we come to 2 here. 2 multiplied by -1. So what are we deleting? We are deleting the second row plus what? The what? The third column there. Second row plus the third column.
Could you delete the first row?
Yeah, you can use the first row.
Okay.
It will give you the same answer, but I wanted us to do the third row. So you can use it as long as it has as many zeros as possible.
Okay, thank you.
So, and then now what remains here is -4, 2, and then 1 and 3 there. Plus 3 here, multiplied by -1. We are deleting the third row plus the third column. 3 plus 3. So what remains there is -4, 2, 3, and then 1. Yep. Okay. So finally, we have -1 outside. So 2 plus 3 is 5. So we have -2 multiplied by, so we have -12 -2 plus, this is giving us 6. So that is +3. And then -4 -6. So finally, this is -1. So -12 -2 is -14. -14 multiplied by 2 is -28. Then plus, this is finally will give us what? So -4 -6 is -10. So this is -30. So this is giving us -1 multiplied by -2, which is giving us 2. Which we get 2. Any question after that? Are we okay? Okay. Now, if we have a triangular matrix 2.3, we have a triangular matrices. Now, if the square matrix, let's say A, if a square matrix A is of the form if this is of the form, let's say here, we have that value there, and then all these are zeros. We have another value there, all these are zeros. We have values there, all these are zeros. And then we continue like that. We have values there. Right. And we can also have this. So we can have values there. You have 0 here. Then we have 0 here, 0 here. Then we continue like that. Then we have 0, 0, 0, 0, and then the last value there. So this is what we call the triangular matrix. The triangular matrix is where the leading diagonal here has some values. So this is the lower triangular matrix. So the values above the leading are zeros. So this is low, and this one is the upper triangular matrix. So these are zeros down here, and then the values above plus even the leading diagonal are not zeros. So to get a determinant here, then what we do is we multiply the leading diagonals. We multiply this by this. So we actually multiply this one, this one, this one, this one, and that. No, and this, because this is zero here. So the ones which are along the leading diagonal, we multiply them. We multiply. So to get a determinant, the determinant of A is equal to the product of all entries along the main diagonal line of A. Along the main diagonal. So the main one is for example, example number 10, compute 4 0 0 0 7 minus 1 0 0 2 minus 6 minus 7 0 and then 5 0 4 and then 2. Compute that. So that is a lower triangular matrix. So either way, you can write the transpose. When you write the transpose, it will still give you the triangular matrix. Upper triangular matrix. So to get a determinant there, then the determinant, let's say this is A is equals to that, then determinant of A is the same as multiplying the main diagonal there. So 4 multiplied by minus 1, multiplied by minus 7, multiplied by 2. So 4 multiplied by this, and then finally by that. So you multiply the main diagonals there. So what you get is 56. Okay. Any question up to that? So either way, even when you transpose this, then the zeros will come down here. So it's still the same thing. You multiply the leading or the main diagonal. 2.4. So there is another way of getting the determinant of a 3 by 3 matrix. So another formula for 3 by 3 determinants. So if we have A11, A12, A13, A21, A22, A23, A31, A32, A33. If we are told to get the determinant of that matrix, then what you do here is you put this A11, A12, A13, A21, A22, A23, A31, A32, A33. Yeah. Since this one is that matrix, then you add the first two columns there. Here. So A11, A12, A21, A22, A31, A32. Okay. You add the two columns, the first two columns. Then after adding that, then you now come end. So we have here positive, 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 and then here we have negative. We have negative there. So what you come and do here is, you see this line here, okay? This one here, and then this one here. So you multiply. So it will now be, to get a determinant here, then it will be A11 multiplied by A22, A11 multiplied by A22 multiplied. So we can actually write as A11, A22, A33, okay? So A11, A22, A33, plus A12, A23, A31, yeah, plus A13, A21, A32, A32. So we multiply this, that, minus. So you now minus. So actually that is like that, and then you now minus. You now minus this one now. How did I write this? Wrote it in a very poor way. Huh? Okay, let's do it again. So let's put here A11, A12, A13, A21, A22, A33, A31, A32, A33. Then we do what? We add A11, A21, A31, A12, A22, A32. Okay. So we take this, check that, and then we check that. So this is addition here. Okay. And then we come and check this, check that, and check that. Okay. So it will now be minus A31, A22, A13 plus A32, A23, A11 plus A33, A21, A12, A12. Okay. It's actually good this way. So that is the easiest way of doing that. So another way is just deleting the rows and the columns. So it is actually the same as. So this is actually the same as deleting. So you can either delete the first row or something like that, or the second column. So in this case, then if we use the first row here, then we can say A11 and then determinant of A22, A23, A32, A33 minus A12, determinant of A21, A23, A31, A33, and then plus A12, determinant of A21, A22, A31, A32. So it's the same way. So you multiply, you get it here. For example, find the determinant of, so example, number 11, determinant of 1, 3, 5, 2, 1, 1, 3, 4, 2. So this example we have done several. So we should bear determinant of should be 50. So what do you do here? So using that special, so you can say 1, 3, 5, 2, 1, 1, 3, 4, 2. You add 1, 3, 2, 1, and then 3, 4 there. Then you do what? You check these. I'm writing this thing in a very poor way. 1, 3, 5, 1, 3. 2, 1, 1, 2, 1. 3, 4, 2, 3, 4. So we take this. Okay. So 3 multiplied by 1 multiplied by 5 plus we take this. 4 multiplied by 1 multiplied by 1 plus we take this. 2 multiplied by 2 multiplied by 3 minus, so that minus, this is actually minus. This is actually minus. So the other one, the first one is this. So you start from the top, which is 1 multiplied by 1 multiplied by 2 plus the next one here is 3 multiplied by 1 multiplied by 3 and then plus 5 multiplied by 2 multiplied by 4 minus this. Okay, so you start from the top. You start from this minus this, and that. So this is giving us 2 plus 9 plus 40. Okay. Minus, this is giving us 15 plus 4 plus 12. Yeah. So what is this? Is this 51? Right? Minus. So this is 19 plus 12. 31. And this is giving us what? 2. So that is giving us 2. Any question after that?
I have a question. I have a question about example 9, real quick.
Okay.
I want to know how come you repeated the same process after you had the 2 by 2 matrix, right there where it says -1 bracket 2 times -1 to your right. How come you did that again within the same bracket but for a different position?
How did we get this -1?
No, I understand the -1. I get why we did the 2 times that whole thing to your right. But how come we did +3 times -1 raised to the 3 plus 3? How come we did that process again?
Okay. So we are deleting this. You see, right? We are deleting. Which one did you delete? Yeah, this one. So it is 2. Yeah. So 2 multiplied by -1.
Okay.
Which one did you delete? The third one. Oh,
Are we on the 3 by 3 matrix?
yeah. Oh, it is here. So we are actually here. So we are using this. Okay.
Okay.
So we are using after you're done with this, you come to the next step here. So so in this case, we deleted this column here, right?
Okay.
That is why we have 1 here multiplied by -1. So we deleted the second row and the third column, which is 2 plus 3 there. You see? So we got this, right? So, and then now we are done with this. We come to the next one. Which one has as many zeros as possible? We could have used this, the first row here, but we decided to use the third column here. Okay. So we put this negative, since we get -1 here, right?
Yeah.
So we put this negative outside. So it is affecting the whole thing, right? Yep. So we have these 2 here multiplied by -1. Which one are we deleting? So we are deleting the second row, right? The second row and the third column. So it is 2 plus 3. Okay. And then what remains is what? -4 here, -2 here, and then 1 here, and then 3 here. Because we deleted this and that. Okay. Okay.
Okay.
So we deleted this and this. So it remains -4, 2, 1, and 3. That is why we have this. Plus, we come to this one. 3 multiplied by -1. We deleted the third row and the third column. So 3 plus 3 here. And then what remains is we deleted this and that. -4, 2, 3, and 1. -4, 2, 3, and 1.
Okay, so pretty much you repeated the same thing because you did both row positions of the third column.
Can you repeat the question again? You said what?
Yeah, so you repeated it again because you had to delete the third row of the third column as well as the second row of the third column.
Yeah, so we are using this. So we are using the third row here to get a determinant. So we are using this. Either you use this, because to get a determinant, you need either use the row or you use the what? Either use the column or use the row. Okay. The one which has as many zeros as possible. Like in this case, we could have also decided to just use this, right? To just use this. But since we have as many zeros as possible here, so we use this. Since this will give us 0, this will give us 0, and this will give us 0. The one which will not give us 0 is this. Okay.
Okay.
So that is why we delete this and we delete that. So we remain with that. And then we use the same process stepwise until finally you get a 2 by 2 matrix, which you can easily get a determinant.
Okay. Thank you.
You can add, so in this case, you can actually get a determinant here using the formula that we've just done. If you get a 3 by 3 like this here, then from here you can use that formula that we have just done. so long as you don't ignore this. So if you use that formula, the last thing that we've just done here, then you can come and use this here, okay? So you can just come and use this here, this formula here, so long as you get a third one. So you can come and add the first two columns here, and then you get a determinant easily. Okay. Okay.
Okay, thank you.
Right. But I think the easiest way is to just use this, delete the row or the columns which have as many zeros as possible. Any other question after that? So make sure you remember how to get it done. So look at the way which is easier. Okay. So the next section that we need to do is the properties. So section 3.2, properties of determinants. Properties of determinants. So in this section, what we will do, the first one is the row reduction. The row reduction. So at the start of this semester, we were given a matrix, and we reduce the matrix to echelon form. So when we reduce the matrix to echelon form, then what we're getting is, let's say we had a matrix which was like this matrix here. Let's say this matrix -3, 5, 2, 1, 1, 1, 3, 4, and 2. So this matrix, when we reduce this matrix to echelon form, then what we get is, let's say, without doing all those stuff, 1, 3, 5, and then we get 0 here, 1, 1, and then 0, 0, and then let's say 2 there. So that is what we were getting actually when we reduce. I did not do manipulation yet. So again, when you reduce, so that one is echelon form. Now there is the reduced echelon form. Reduced. Now the reduced is where now the main diagonal here should be 1, right? The main diagonal here should be 1, as long as the one which has a pivot. This one has a pivot position, the pivot position, pivot position. So if you have the pivot position in each of the rows there, or the columns, then when we reduce it completely, then what do you get? Since you were making the ones which are above it to be zeros, then when we reduce to reduce echelon form, then we get what? An identity matrix, right? We actually get an identity matrix. So since we are making this one to be 1, we are also making this one 1, this one 1. So the ones which are above the matrix should be what? Should be zeros. So what you get is an identity matrix. Okay, so we can meet on Friday and then this section. So do you want homework for spring break?